我今天想要分享一下 openVM 的大概的架构。然后我在看 openVM 的时候，我大概有知道它的一些特色，就是有人说它是 no CPU design， 然后它可以就是具有 customized 的 ISA。所以我有3个问题，其实想要回答，是想要看 what is a no CPU design and how it's handling unbounded program proving, and then how to add the custom ISA to it. So this is gonna be like a high level because I haven't finished all the digging into the code and then the implementation. So openVM is more like a structure, and inside of it, the minimal, like the modular, the minimal unit, it's chips. And other than chips, there is 3 like very important components. One is message bus. Memory bus. So these are the 3 main components. And these are the main design that makes openVM itself to be CPU-less and also very modular. So a chips can be implemented in this way. So there will be a core implementation of the instruction that this chip is taking care of. So there is a core component here. And then there is another component called adapter. And the adapter itself is mostly taking care of the interaction between the chip itself and the message bus. So how it interact with message bus, there's you can directly interact with the bus, but because the bus implementation is very like low level, so it's recommended to go with a bridge. So actually, there is a memory bridge. And then these 2 together, there is an execution bridge. Okay. And underlying of the memory bus, it's doing a range check. I'll write here, so range check. Underlying of the programming bus, it's doing a lookup. So it's looking up to the ROM and then take the instruction to execute. And then the execution bus is doing permutation check. So memory bus is taking care of the offline memory checking and then manage the initial and final memory state. And actually for memory bus, there is 2 ways. So there is 2 kind of chips. One is volatile, and then another one is persistent. So when you are using the VM, you can specify you are using a volatile memory for this one, or you're using a persistent memory of this one. And these 2 are actually used in the recursion structure when it's trying to prove the unbound program execution, where the recursive one, they're using the volatile ones. And what's the difference between these 2? So volatile ones is doing the arbitrary initialization for the memory, and it treats all the memory as like the 30, like all the cells as 30 to start off, and then it doesn't emit any like initial or final state. And persistent one is managing Merkle tree for the memory, and then at the end they will have a final state root published, and it also taking in like a initial state root, and then check that the initial state matches to the initial state root. Yeah. And for memory bus, the message format is like this. So it's taking in the address space, the pointer, the data, and then time. And then for program bus, the message format is like this. So it's taking the program counter, OP code, and the operand. And then this one is taking care of the correctness of the instruction and function. And then execution bus is having PC, the program counter, and time as the message format. And this one is taking care of the continuity of the program counter. So these two are combined as execution bridge for a reason, because most of the time when you're doing the execution, you need to look up like what is the next one to execute, what is the current one to execute. So the steps, they have to be like synchronized. So that's why they have this execution bridge. Whenever the chip try to execute something, they'll just call this one. So yeah, this is like the high level of the implementation they're going with. And for this modular design, whenever you wanted to add a customized ISA, it's actually easy because everything is like like pieces. So if you wanted to add like ISA, you just customize yourself a chip, and that is defining what's the doing the core, defining the core, defining the adapter. These are like writing the AIRs for the interaction. And then you will have an extension there. Yeah, so let me talk about how it's doing the unbounded program proving. So yesterday Uma mentioned the tree structure, and this one also follow the same pattern. So I quickly draw a root here, like a tree. Okay, so on the first layer, we have this application VM segmentations. So it's the unbounded program we want to prove, and then it's cut into segments. And then in this VM, they are using, so VM from this level are different from the VM config they're using like on the higher level. So below this level, it's using continuation enabled, which means they're using a persistence setting for the memory. And from this level up, they're using like a volatile memory setting. This is because under this layer, we need to take care of like the start of this. The start of this has to be matching with like the end of this. So the input output at this stage still matters. And then from this stage up, they're making it into like they're proving the program as like the program itself only. So it doesn't have to take care of like the input and output state. And the thing that makes this very interesting with this modular design is that when they're doing this, they actually just create a chip like extension chip. So they have this default extension. That is like taking care of the recursion and then specifically for proving the execution of the VM itself. Yeah. So I think that's about it for the topic I prepared today. Yeah, thank you.